Hi everyone. In this chapter we were going to be reviewing factoring. In this lesson we're going to look at solving by factoring.
So we want to take that previous lesson basically just one step further and use it to solve an equation, specifically a quadratic equation at this point. And you do that by factoring. Now, just so that you're clear on this, when we talk about solving, okay, what we're looking for here ultimately is what x is equal to, okay? Sometimes I've seen people factor and then stop right there, even though they've been asked to solve. And that is, factoring is an important step in that process, but that's not the final solution here. So we want to find the solution for x, which means finding the roots of the equation, finding the zeros of the function, or finding the x-intercepts of the graph. And the way that works is basically this. When you take a quadratic, okay, and you are able to factor it down so that you've got something times something, like a times b here. I'll zoom in a little bit on this. A times b, and you know that this is equal to 0, okay? And this is important. You really want that quadratic equal to 0 before you factor, okay, because it's the only way we're going to make this work here. Because if a times b is equal to 0, then you know one of two things must be true. Either a is equal to 0, okay, or b is equal to 0. That's the only way their product could equal 0. Now, if you make it anything else, then you introduce a whole bunch of other options, okay? Like, for example, if a times b is equal to 1, well, they could both be positive 1. They could both be negative 1. One could be 2, one could be a half, or the other way around. Like, there's lots of different ways to get 1 here. However, okay, no matter what a is, a could be anything, but if the product is 0, then b must be 0, okay? And so that's how we think this thing through to solve it. So that's what we're going to do as we go through and solve the next set of questions here.
Look at the following examples.
Okay, so to do this, we're going to solve by factoring here. So x squared plus 5x plus 6. Okay, this is going to equal 0. So I can break x squared up at x and x here. Now, factors of 6 that add up to 5 will be 2 and 3. Now, bear in mind, the product of these two is 0, which means either x plus 2 is equal to 0 or x plus 3 is equal to 0, in which case x here would equal negative 2 when I bring that over, or x is equal to negative 3. Now, just watch this. If x is negative 2, this first factor is 0. Now, granted, this one isn't 0. If you plug negative 2 into that, you're going to get 1, but 0 times 1 is 0. And you get a similar sort of thing if you plug negative 3 in. Negative 3 makes this factor equal to negative 1, okay, but it makes this one equal to 0, and when you multiply those together, you get 0. So that's why we can say here that our solutions are negative 2 and negative 3. Let's take a look at this one. You've got two terms here, so I suspect this is going to be a difference of squares. And I got a square minus a square, so that's right. So this will be x minus 8, x plus 8. Multiplying those together to get 0 means either x minus 8 is equal to 0, or x plus 8 is equal to 0, in which case x would be equal to 8, or x would be equal to negative, I don't know why I wrote 3 there, negative 8. I'll just change that real quick. And there you go. Okay, and those are our two solutions. And again, I can walk this one backwards here, but this is what we're looking for. This one right here is already in factored form. So I want you to think about it like this. Now, you've got this that we pulled out. This is probably a common factor to both of those. So either 2x is equal to 0, or x plus 3 is equal to 0. That's the only way we're going to get 0 as a product. So divide by 2, and we're simply going to get x is equal to 0. Move the 3 over, and we're going to get x is equal to negative 3. Now, notice, up to this point, 0 has not been a solution all the time. Hey, well, sometimes the mistake that people make here is they assume as we go through this that 0 will always be a solution. And that's not true. It's only a solution if you get a factor of x all by itself, not added or subtracted anything. It can be multiplied or divided by some number here. That'll still be 0 here, but if it's added or subtracted to something, that's when you get a different number showing up as a solution. 2x plus 5. Well, okay, 2x plus 5 is a linear factor. This isn't a quadratic. It doesn't require factoring. It's already broken down as far as it can go. So bring the 5 over. You get 2x is equal to negative 5 when you move that to the other side. And then we're going to divide by 2. And we'll get that x is equal to negative 5 halves. And that's the solution to that little equation right there. Now, the reason why this is here is because it's going to influence how you answer questions like this one. So in this case here, again, this is in factored form, so I'm just going to jump right to looking at the individual factors. So either x minus 2 is equal to 0 or 2x plus 1 is equal to 0. And in this case here, you would simply bring the 2 over, x is equal to 2. But here, this is a two-step process. The first thing you're going to do is take over the term that doesn't have the x in it. And so we're going to subtract the 1 from both sides. Then what we're going to do is we're going to divide by 2 here. So x is going to equal negative 1 over 2. And those are your two solutions. Okay. This is always a little bit trickier because of that one extra step that it requires. Okay, let's take a look at this one right here. Now, okay, this one here, granted there are two terms, and I'm seeing a square here, and 4 is a perfect square as well. But, 32 isn't. So what I'm going to do is just pull out a common factor of 4x here. And that'll leave me with x minus 8 is equal to 0. Now, this question is similar to actually the one right above it here. Okay, so I've got two factors here, so either 4x is equal to 0 or x minus 8 is equal to 0, and in this case here I can tell you that either x is equal to 0 or x is equal to positive 8. Okay, and those would be my two solutions here. So just watch out for that. That is not a difference of squares. Kind of looks like it when you first see it though. Okay, down here, again, this is already in factored form, so I'm good to go here. I just got to take the two factors here and set them both individually equal to 0. Bring over the 1 in this case, and then divide by 2. So x is equal to a half, or 2x is equal to negative 3, and then we divide by 2, and we're going to get x is equal to negative 3 halves. And again, here are my two possible solutions for that. 9x squared is equal to 16. Okay, now in a case like this, you could do this one of two ways, and we had shown this before here, but I'm going to be really consistent with what I'm doing with all of this here. I'm going to bring the 16 over, so it's 9x squared minus 16 is equal to 0. This is not maybe even the quickest way to do this. A quicker way might be to divide by 9 and then take the square root, but every other question here has been factored, so let's do that with this one. And this is a difference of squares here, so I get 3x minus 4, 3x plus 4 equal to 0. So 3x minus 4 equals 0, or 3x plus 4 is equal to 0, and then bring over the 4, and then divide by 3. So that's going to be, first of all, 3x is going to equal positive 4, then divide by 3. Over here, when you bring over the 4, it'll become negative, okay, because it's going to switch signs, and then I will divide by 3 again. So positive 4/3, negative 4/3. Here, looks like a difference of squares, but 5 and 45 aren't perfect squares. But 5 is a common factor there, so I'll factor that out first. And I'll get 5 times x squared minus 9. And now what I'm looking at is a difference of squares. And this will become x minus 3, x plus 3 is equal to 0. Now, I'm going to set some factors here equal to 0, but I want you to understand here that I'm not going to set 5 equal to 0, because that's just kind of goofy. 5 isn't 0. Like if you do this, go, oh, okay, 5 equals 0, x minus 3 is equal to 0, x plus 3 equals 0. What? That doesn't make any sense at all, right? There's no variable here. So there's no way that that term could be equal to 0. So 5 doesn't equal 0. But here, with the variable, it is possible that x could equal 3, just like it is also possible that x could equal negative 3. Okay, so those are both the two viable solutions here. Over here, this one right here, again, it sort of looks like a difference of squares, but that 3 kind of kills it. I want to factor that, but it's going to look weird if I try to split that up here. So what we're going to do here, this now will probably be the first one where it make more sense for me to go the other way around this problem and make this 3x squared is equal to 16, and then divide by the 3, 16 over 3. Now, I'm going to take the square root of both sides. Okay, so 16 over 3. And then bearing in mind that I should have the plus or minus here. Okay. Now, you should remember from a while back that you can distribute that radical to the numerator and denominator here, and so this would end up being plus or minus, well, the square root of 16. Sorry, if you want to think of it like this, square root of 16 over the square root of 3. That's going to be plus or minus 4 over root 3. And now the expectation, I suspect, is that that you will rationalize this by multiplying by a root 3 numerator denominator. So this will be plus or minus 4 root 3, and then the root 3 times the root 3 will just get you a 3. So a little bit more complicated of an answer. This may be as far as they expect you to go, but you might be expected to do that as well. Just something to think about.
Now we're going to look at solving by using the quadratic formula.
All right, now another way to approach solving, particularly if you're dealing with quadratics, is to use the quadratic formula. Okay, oftentimes these things can be difficult to factor, and when they're difficult to factor, just jump to the quadratic formula. Don't even waste any time. I'd say if you look at that thing for a few seconds here, even if you can't see how to factor it, jump to the quadratic formula. So here's the formula. Let me just zoom in a little bit here, and remember the way this thing works here. You use it if you're solving an equation of the form ax squared plus bx plus c is equal to 0. And if you're missing one of the two terms b or c, you have to assume that b or c are equal to 0. Now, normally you'd think I would say a, b, or c in here, but if a isn't present, it's not quadratic, and so you wouldn't use this to solve it. Okay, but if either b or c are missing, just assume those letters are 0. Now, let's take a quick look at some questions here.
Now look at the following examples.
Okay, here we go. We're going to solve this one. We're going to use the quadratic equation for this, or quadratic formula, I should say, not the quadratic equation. So, in this case here, remember, a is 2, b is going to be negative 12, c is going to be 11. So, x is going to equal negative of negative 12. Sometimes that's a hard thing to remember to do that. Okay, but the second negative there. But remember, the formula is negative b, and in this case, b is negative 12. Plus or minus the square root of, okay, it's negative 12 squared, but what I've written there right now is incorrect. Okay, please listen to this. This is incorrect. I see so many people do this over and over again, and then they get frustrated and they wonder, why isn't this working here? Because when you write it like this, you're not including the negative with the square. You're only squaring the 12. You absolutely must put parentheses around that. Okay? You have to do that. So please bear in mind that that's what you got to do. I'm just trying to help you guys out so you don't get kind of caught in a very predictable trap here. And now this is going to be minus 4 times a times c. This will be all, whoops, hold on a second, something underneath there. All over 2a. A in this case was 2. All right, now let's simplify this a little bit here. So this is going to be positive 12 plus or minus the square root of, well, this is going to be 144, and this is going to be minus 88 all over 4. Okay? Now we're going to rewrite the, oh, don't have enough room there. So this is going to be 12 plus or minus the square root of 56 over 4. All right, well now the expectation is going to be that we're going to be able to tear apart that 56. Now, let me show you how I would normally do this here. I'm going to just do this in a little scrap here. The square root of 56, okay, well, when I write 56 in terms of its prime factors, I can divide 56 by 2. That'll get me 28. I can divide 28 by 2, give me 14. I can divide 14 by 2, but that leaves me with 7. Okay, so here is root 56, or, well, in 56 written in its prime factors. Now remember what a radical does here. It takes that pair and spits out a single out front. So this becomes 2 out front here for that pair, root. And then the 2 and the 7 didn't have pairs, so they have to stay behind here. 2 times 7 is 14. So root 56 is going to reduce down to root 14. So this is going to be 12 plus or minus 2 root 14 over 4. Whoops, sorry. Now I still have one more little bit of simplifying to do here, and I wish I had given myself a little bit more room, so I'm just going to write it right here. I want you to notice that you cannot just go, 12 divided by 4, 3, done, and think that that's correct here. You can't do that, okay? Just for example here, if you've got 3 plus 5 over 3, okay, think about what that is. See, most of you, when you look at numbers like this, not a problem. You'd say, that's 8/3. It's 8/3. But a lot of you want to cancel it and just say, no, it's 5 or it's 6, depending on how you cancel that, okay? So, and that's not true, because just like multiplication does this, if you have A times B plus C, just like multiplication distributes, so that would be AB plus AC, so does division, okay? So does division. So if you've got, for example, A plus B divided by C, that is the same as A over C plus B over C. That division there distributes those terms as well. So if I'm going to do this, yes, 12 divided by 4 is 3. But at the same time, I have to go 2 root 14 over 4. Now, I can't do anything with the root 14. You might say, well, there's a common 2 between there. This isn't 14, though. This is root 14. Root 14 isn't divisible by 2. 14 might be, but not root 14. However, the 2 in the front is. And so what I can do here is I can make this, for example, just root 14. Now, it was 2 over 4. I'd make that root 14 over 2. If you don't like writing it that far, like the idea of distributing it to both here, you can simply look at this again, and I'll maybe write this down here. I'm starting to get kind of tight here. There is a common factor of 2 to all those. If you want to leave everything in the numerator, if you take a 2 out of the 12 and the 2 root 14, you'll end up with 6 plus or minus root 14, but that will leave you with a 2 at the in the denominator there. So either one of those is correct. Okay? Let's take a look at the next one. 6x squared plus 2x minus 1. Okay. Now in this case here, x is going to equal negative 2, the b value, plus or minus the square root of 2 squared. Now in this case, because there's no negative in front, that actually works out okay. You're not likely to make a mistake there. Minus 4 times a times c, all over 2 times a. So negative 2 plus or minus the square root of, now this is going to be 4. This right here, 4 times 6 is 24, negative, and the negative is going to be positive 24. So add that 4, this will be negative 2 plus or minus root 28 over 12. Okay. Now, let's take that 28 and simplify it. Okay, so root 28, well, that's going to be equal to root, you can take a 2 out of 28, that leaves me with 14, 2, and then 7. Okay, well there's my pair of 2's, so I can yank that out, and that'll be 2 root 7. So that's how root 28 simplifies. So this will be negative 2 plus or minus 2 root 28, sorry, not root 28, root 7, just dealt with that, over 12. Now, whoops, sorry about that. These guys right here, it's just the 2, and the 6, the 12 here that I'm worried about here. I need to distribute this to both of them. But notice that there's a common factor of 2 to all of those, so I can just divide out the 2 from everything. So this will be negative 1 plus or minus root 7 all over 6. And that's about as good as that's going to get. Let's do one more. So x in this case is going to equal the negative of negative 6. So right away I know that when I move inside my radical here, I'm going to have to pay attention to that. Brackets around the negative 6. Got to put brackets around that negative 6. So negative 6 squared minus 4 times a, which was 1 in this case, times c, 13. All over 2a. Okay, so that's going to become positive 6 plus or minus the square root of, okay, this is going to end up being 36, okay? And then 4 times 13, whoops, so I'm just going to do it on my side, on the calculator on the side here, just to make sure I get this right here. 4 times 13 is going to be 52. And then 2 times 1 is 2 here. Now, the little bit of math I got to do here is this 36 minus 52. So 6 plus or minus the square root of negative 16 over 2 here. Now this one's a little bit of a trap, I'll be honest with you. Because you're going to look at that and say, 16, I can take the square root of that, it's 4. But no, you can't. You're not going to get a real number when you take the square root of a negative 16. Okay, this is what we would call an imaginary number, and altogether, when you combine it with all these other pieces, it's called a complex number. It's not a real value. It's not something you can plot on the regular Cartesian plane here. So as a result, our conclusion to this, as soon as you see that showing up in there, is that this is there's no solution. And that is as far as you can go. And that's okay. That's okay. I've seen all sorts of students that'll come through and do a question like this, and when they see that, they assume that they've done something wrong. And actually, it's not a bad assumption at first. But if you go through and check everything, and yeah, sure enough, I'm getting a negative in that radical, this is what you write as your result. There's no solution. There's no x-intercepts. There's no roots, no zeros.